Hello everyone, I am Shiv Prakash, Research Scholar, Department of Electrical Engineering, IIT BHU, Varanasi. I am here to take in your problem solving section. So,
Good evening, sir.
good evening to all.
Sir, this session is for assignment 1 and 2 or basic?
Yes, simply problem solving session. This one. I
Oh,
want to.
you not focus the assignments.
No. I am
Okay,
focusing
sir.
only the numerical words.
The question is very tough, so that only asked you.
Okay, don't worry. I am here.
O-
If you have any doubt, you can ask freely.
Okay, sir. Okay. Thank you, sir. Thank
Okay, this is the basic electrical circuit. Simple. Electrical circuit means the connection of some elements, electrical elements. Electrical elements mainly passive and active elements. Active and passive. Active elements, which one provide the power to the circuit, and passive element is when they dissipate the energy. Active elements we have like a source, and passive element simply a sink of. Yeah, someone asking, sir, we the notes we shared. Yeah. I'm share this notes at the end of this one, and meeting recording also on the YouTube. Active element mainly voltage source and current source. You know about this one. And electrical elements passive simply RLC. Link I will share after this class. Resistor, inductor, and capacitor. These are the passive element in electrical circuit, and the active element is simply voltage source and current source. Okay, let's try to connect a circuit and find the system. Simply you know about the voltage and current form, equation, Ohm's law simply is equal to I a simple circuit. If a resistor here and current is passing through it, I, and there is a voltage drop, which one depend on the current passing through it. Or is the law is simply say that ratio of voltage and current will be constant at constant temperature. Okay, let's try the first question. A time varying current IT is equal to T square plus 5T plus 6 is passing through a surface with a cross section area of 10 centimeters square. Then what amount of charge has flown through the surface in the 10th second? It's saying simply a surface is a surface and area is given 10 centimeters square of the surface total area. It says that a current is passing through it like that IT. Then asking about the what amount of charge has flown through the surface in the 10 second. Is asking about the charge flowing through this surface at a 10th second. You know about this one. For the charge there is a two formula. Q is charge, that is equal to C, and V. C is capacitance, V is voltage. Another formula for the current is dq by dt. It means number of electron flowing per second is the current. Q, what is Q? Q is simply electrons, a charge, electrons carrying a charge, a negative charge. If electron is moved from one place to another place, then the current will be flow. But current is depending on the charge and time. How many charge flowing through a second is known as the current simply. Rate of change in the electron like that. In this question is simply asking about the amount of charge and current is given. Then you have to choose this formula to solve this. Dq by dt is equal to current. Simply we transfer this one, dq is equal to I into dt. You can apply integration on both sides. Then what happens? This will be dq integration of I into dt. What is I? I is given in the question, t square plus 5t plus 6. Okay. So I is equal to t square plus 5t plus 6 is given in the question. So that this one be 1, integration of 1 is same q with respect to dq is q. Q. Integration of this one, I is t square plus 5t plus 6 into dt. Simply you can integrate this one, t cube by 3 plus 5t square by 2 plus 6t. Okay, then what is a q? Q asking at t is equal to 10 second. Then this will be 10 q by 3 plus 5 into 10 square divided by f2 plus 6 into 10. This will be 1000 divided by 3, 33, 333.33 plus this will be 100 by 2 is 50, 50 into 5 will be 250 plus 60. You can add all of things and this will be 643.33 coulomb is charge. Simply this amount of charge is flowing through the surface at time t is equal to 10 second. Okay. Next question I have taken from the same thing. Let's say this is V1 and V2 are two constant voltages maintained by the external voltage source. These are two voltages V1 and V2 is a fixed voltage. But given that V1 has greater potential than V2, it means V1 is greater than V2. An electron is placed between the line joining. Here, electron is placed between V1 and V2. So how will the electron move? You know about simply current flowing from higher potential to lower potential. It means current is flowing from V1 to V2 because of V1 is greater than V2. But electron is flowing to opposite of this one. Then the electron is moves towards V1 where is a higher potential because of the electron have a negative charge. Then electron always attract from the positive terminal. That's why the electron flowing towards the more positive is there towards V1. The electron will move towards V1. Yes, this one is correct. The electron will move towards V2. No. Electron will stay at rest. No. This one is possible when V1 is equal to V2. In that case, electron is stay at the that point. The electron will move perpendicular to the line joining V1 V2. No, this is not possible because the electron always flowing following the shortest route. Okay, so in a simple way you can find. Next one, in the given circuit below, find the current
Sir,
I1. Yes,
sir, can you explain first problem one more time?
first one, this one.
Yes, sir.
Okay, okay, no problem. In the question is current is given simply and asking about the charge. For the charge calculation, you simply know about the two formula. Q is equal to Cv, where if the capacitance is given in their circuit, then you can apply this one formula. This was a voltage, this was a capacitance, and this was a charge. But current have the property which one is saying that the rate of change of flow of electron is the current. It means how much electron is flowing per second is known as the current. You know about this formula is a dq by dt, rate of charge per second or rate of charge flowing of charge. This formula is for the current. If the electron is flow, electron have a simply charge. So in this case, current is given, but charge is asking in the question. For this one, if we integrate a any differentiation, then the quantity is only this one. We can simply do for the go for the integration of this thing like a current. After that, we have to integrate the both. Integration of one, this one is simply one of with respect to q, this one simply q, and this is the integration of current I with respect to time. I already given in the question, this one t square plus 5t plus 6, simply put here, then integrate of all of them like this one, q is equal to t square plus 5t plus 6, integrate this one. If you integrate, then you will find this charge. Then at place of t, question in the question is given as t, asking about the charge at t is equal to 10 second. Then simply put the 10 at place of t, you will find the final charge. It's okay. Have you any doubt here also?
Sir,
Yeah.
I had a
No,
doubt. Sir,
no doubt, sir. No.
To integrate it, we need two limits, sir. Right?
Yeah, there is two types of integration. Na?
Mm.
Now simply
But they asked what amount of charge has flown through the surface in the 10th seconds. That means it is indefinite integration or definite integration, sir.
indefinite integration, because of this one is not mentioning, only asking at the 10th of second, not the totally 10 second. At that point is asking at 10th
Okay, sir.
second, at 10th second.
Mm.
If
Okay,
we
sir.
if there is asking about the how much time passing through 0 to 10 second, and that case you have to use the this one definite integral.
Okay, sir. I think it has a definite integration. So I asked another time.
Okay, okay, but is asking only 10th of second, not 0 to 10 second.
Okay, sir.
Yeah. In this case you also add some constant, but in this case charge is 0 because of current is not passing through it at initial, that's why the c will be 0. Then both are the same thing, definite or integral, indefinite. Okay, let's start. Second question is completed, I think. Third one, in the circuit given below, find the current I1. This current given that I is equal to 3 milliampere. Yes, yes,
Sir,
yes.
can can you scroll the page upside?
Yeah. Don't write words by words. I will share this script to the you on the link given in your
Okay,
MTT on PTL. Don't worry. Video lecture and this script will sharing to you. Okay.
Thank you, sir.
Yeah.
thank you, sir.
Okay. Here asking about the current I1. The voltage given, current is, but I is given 3 milliampere. This I is given, and this is the infinity branch. And current flowing upward. This one downwards, up, downwards, upward, downwards, upwards like that. And the resistance is all resistance is same. Then you have to first of all find the I1. What about this one? You know about nodal analysis. Nodal analysis means I would say at this node all the branches is connected this node. This node is from here to here to infinity. Incoming current and outgoing current, sum of the algebraic sum of incoming and outgoing current will be zero. Kirchhoff current law. Okay. Then simply add all of thing. I1, suppose incoming is taken as the positive or outgoing is taken the positive, incoming taken as a negative, anything you can say. Then this was the incoming, take as a incoming is a negative, outgoing is a positive. Then this one the income outgoing I, this is the incoming I by 2, this outgoing, so incoming is taken negative and outgoing is a positive. I by 4 minus of I by 8 plus I by 16 minus I by 32 that equal to 0. Algebraic sum of all current connecting at a branch connecting at a node will be 0. Now what is the I1? Simply you can transfer this one that side. I1 is equal to I minus I by 2 plus I by 4 minus I by 8 plus I by 16 minus I by 32 plus to infinity. Okay. Simply you can common I here, and 1 minus of half plus 1 by 4 minus of 1 by 8 plus 1 by of 16 minus 1 by of
Sir,
32.
can you please elaborate this?
Okay, okay, fine. Simply you know about the KCL, Kirchhoff current law. It says the incoming current, algebraic sum of the incoming current and outgoing current at a node at a point will be 0. It means if you take as incoming current as a negative, outgoing is current is a positive, same thing you can opposite, take an opposite also. Incoming current you can take positive, outgoing current you can take a negative. Okay, and connect all of thing and sum the all of thing with a sign, then all of it will be 0. This so is the KCL. Okay, then in this question, you can see here I1, I by 2, I by 4, and there will be a incoming upgoing arrow is there. If downside is given, it means I have taken as a outgoing or upward arrow, I'll taken as incoming current. Then incoming current taken as negative. I've taken here negative. You can take as a positive of incoming, and outgoing is a negative. Anything you can take. Okay. Then
Sir, current direction clockwise or anti-clockwise, sir? The circuits.
this is not confirmed that you can't be say anti-clockwise clockwise. There is a given already arrow is there. Then you have to should follow the arrow. If they
Okay, sir.
uh,
Thank you, sir.
I1 have some arrow na, I1 I by 2 all of have some arrow, then you have to follow that one only. If there is any change
Okay, sir.
in final one, if you calculate all of thing, if there is any changes a positive or negative in the final answer, then you can say this arrow will be reversed. But if in the circuit is given the arrow or mark is given how where is it flowing current from where to where, then you have to choose in that one as a sign, positive or negative. Okay.
Okay, sir.
For the reference, the same thing if I am taken as a incoming at this node, all of thing is incoming is like that, outgoing is from far from here. Then outgoing it in this case is downwards, incoming is upward. Okay. The all incoming, this one will be I taken negative, all outgoing I will taken as a positive. You can reverse also, both answer is same. Then this one is the incoming current I1, I will take it as a negative I1. I have outgoing current, I have taken as a positive I. Then I by 2 is incoming current, I have taken as a minus of I by 2. I by 4 is outgoing current, I have taken positive I by 4. Like that I will taken all of things to infinity. After that I transfer the I1 to the right hand side. Then this I1 will be here, this I1 you can say this will be here. But I can same thing opposite here, then I will taken here I1 like that. Okay. Then you can common I, and all of thing is the same. Then you can see all of thing is in GP. Who know about GP in inter college? I think geometric progress. All of the sum is here. Then we have to find A and R. What is the R? R is a common ratio. Common ratio is second one to the first one. Minus of half by 1 is equal to minus of half. Okay, this was a common ratio. R1 R is the common ratio. A is the first element. A 1 is the first element. A is equal to 1 here. Then in GP, S is equal to suppose A plus AR plus AR square plus AR cube plus dot to infinity. Then in this case, the sum of all of things is A divided by of 1 minus R. Is the sum where R is less than of 1. Oh, sorry, less than 1. Same formula you can take here. I1 is equal to I, and sum of all of things is A is here is 1 divided by of 1 minus R. R is here minus of half. Sorry, minus of half. You can solve I 1 divided by of 1 plus of half. This will be I 1 divided by of 3 by 2, or you can say I1 is equal to I into 2 by 3. In your question, I is given is as a 3 milliampere. Then we put the 3 milliampere, 3 into 2 by 3 is equal to of 2 milliampere. Okay, this is a milliampere, this is also milliampere.
Sir,
Yes.
if you don't mind, once again explain this problem, sir.
Okay. Where is problem? At starting or after this one? Okay, I explain as once again. KCL it says that
Sir, one issue, sir. Sir, you solution is third line, sir.
yeah, yes,
Third line after that you matlab um, understanding formula.
yes, yes,
So, sir, 1 by 2, 1 by 4. So, sir, 2 matlab uh, I sir Hindi speaking.
yes, yes. You can speak. Don't.
हाँ तो सर 1/2 1/4 जो है सर
Hmm.
उसको अगर हम एलसीएम में कन्वर्ट करें तो कुछ दिक्कत होगा सर.
LCM.
हम्म.
You say that you can convert all of things. This two is in LCM. This two is in LCM like that. Huh? Total.
नो सर टोटल.
Total you can't be convert into LCM because of this is the infinity term series. Then how can you
Okay.
say the what is the next?
So
Sir,
this
here
situation this formula is applied,
Yes,
right?
yes. Then you
Okay
have
sir,
to make
but
this one in a series or some other way to take all of things. Yes.
oh sir this formula is I don't understand, so you sorry sir you
Okay.
speak this understanding for Hindi sir.
Yes. You can speak in this.
Sorry sir, I थोड़ा समझ आता है इंग्लिश.
हाँ ठीक कोई बात नहीं.
Thank you sir.
sir,
There's a
hello,
two.
sir.
There's a yes. Om Singh.
Here a common ratio you told R.
हाँ.
So that R is minus half by what? So that minus half is the common ratio.
Yes. Common ratio is taken from this one to this one, from this one to this one. All will be same.
Okay, so you have taken common ratio.
Yes. All should be same. If there is a not same, another thing will become. Then that time you can't be apply GP. Can't apply this formula. But in this,
Sorry, sir.
in this type of question, maximum time you will find this one. Or GP or EAP.
Sorry, sir. Exact formula is like R is equal to what by what?
This one.
Okay. Yeah.
Half I simply common ratio is simply I written all of things. Common ratio is it means this one divided by this one minus of half
Oh, okay.
the divided by 1 equal to it should be same.
Okay.
Sir, can we talk regarding
1 by divided by minus of half is equal to minus of 1 by 8 divided by of 1 by 4 like that. This one to
Yeah.
this one
Got it.
it should be same. This is the common ratio.
Yes, that makes sense. Thank you.
Yes. If there is another thing, then you can't be apply this formula. Then you have to make this term like that. Okay. Other doubts?
Sir, why A is equal to 1, sir?
This is a one, na? A it means first for term. I think
So
I.
whatever
Yeah.
we have to consider first term.
Yeah. A is the first term only in this formula. In GP is
Okay.
geometric progress. A it means first term or it means common ratio.
Okay, sir. Thank you.
In a AP arithmetic progress, there is a common difference between two terms like 1 2 3 1 2 3 4 like that. This is the in GP to infinity. This type is the common difference between two, single one, I think. Okay, can I go next? Question number 4 is saying the consider the flow of electrons across a given cross-sectional area from point A to point B over a certain time interval. Given that the number of electrons passing through the cross-section area over a period of 5 seconds is this one, then calculate the current flowing through the given cross-section area. It is given 2 points A and B. There is some wire. There is a cross section. This one area. 2 points is given. Given that number of electrons passing through the cross section over a 5 second. It means in a 5 second, current electron is flowing through this one is given as 6.25 into 10 to power 19. This much of electron flow in 5 seconds. Okay, this is not a charge. Carefully read this question. This is not a charge. This is the electron. This amount of electron flow in 5 seconds. But in the current equation, you know about dq by dt. Yeah, there is a charge. Then a single electron has some charges. You know about this one? Electron?
Sir, this question we calculation from this derivative, sir.
No, this is not a derivative. Simple, you can calculate. Like
Okay, sir.
simple, you can see here is given the question is a total of this much of electron passing in 5 seconds. It's given in the question simply. It means 6.25 into 10 to the power 19 electron. This amount of electron passing in a 5 seconds. Is asking about the current. What is the current? Then we know about the a simple electron carry a charge of 1.6 into 10 to the power minus of 19 coulomb. This charge is this amount of charge is carried by the a single electron. Then this much of electron, how much charge will be passed carry? Just simply total Q 6.25 into of 10 to the power 19 into 1.6 10 to the power of minus of 19. This is the total charge. 10 to the power minus 19, 10 to the power plus 19 will be cancelled out. 6.25 into 1.6, it will be about 10. Okay, then what is the I? Simply total charge and total current. Total time. So total charge, total time. 10 divided by of time is 5 seconds. Then this amount of current is flowing. Simple. Okay.
Option B.
But here is the some critical options there. 1 ampere of
Option C.
this is the 2 ampere flowing from B to A. The charge electron is flowing from A to B. That's why current is flowing from B to A. C is correct.
Sir, how understand for this direction A to B, B to A, sir?
Because of the simply given in the question of electron direction. It's given the consider flow of electron across a given cross section area from point A to B. It's given in the question. If the electron passing from A to B, then we know about the current is simply flowing to the opposite of the electron. Then the current is flowing from B to A. Okay. Next question, in the given figure below, determine the voltage that V1, this voltage at 5 seconds, 5 millisecond, the capacitor voltage and inductor current at 0 is equal to 0. At time 0, it means here 0. It means the initial voltage and initial current of the capacitor and inductor will be 0. Okay, he asking about the voltage V1 and current waveform is given. Okay, I I1 written as a bit bigger this one. This is a plus 5, this is a minus 5, this 1, 2, 3, 4, 5 millisecond. Current direction, current is given as like that. Okay, for this one you can apply KVL, and this is the
Yes, sir.
yes, yes. Yes, yes. Any doubt? Then what is the V1? V1 is simply VL plus
Sir, these are the problems in asked in previous questions, isn't so?
where?
Sir, may I know this is the questions were asked in previous year, isn't so?
I think this is asking in the previous. I think the previous assignment, na?
Okay, sir. Shall we solve week one assignment? Whether I don't know, that is why I am asking.
I think this one will be in type previous years. I think assignment. This question.
Yes, sir. Like
Thank you, sir.
after this question, if possible, like week one questions we can review, sir. Like you can give hints like how to solve.
Actually, I can give the hint only. I can solve that question because
Yes,
of
sir.
this is
Yes.
the depending on your marks, final marks. That's why you can't solve
Yes.
that question.
Yes, sir. No need to
Mm.
solve. At least
Okay.
hints like some doubts
Okay,
you can
okay.
clear.
That's why I am solving the previous year question because of some question is similar to that question, and that's why
Yes.
I am solving previous question. I think maybe there is some question will be same to similar to this one. Okay. This one is simply if
Thank you, sir. Thank you for your information.
okay, okay. V1 is simply VL plus VC. Then first find VL. We know about the VL in an inductor voltage is it L di by dt, and a capacitor voltage Vc simply 1 by C integration of I into dt. All of you know about this type of formula, na?
Sir,
Yes, sir.
Okay.
sir, without applying KVL, you wrote V1 equal to VL plus DC. How, sir? Without applying KVL?
Because of this is the you can apply KVL. This is coming from KVL only. Without KVL, you can't say this is the same thing. If you take a VL VC, then simply apply this one KVL in the loop. This is plus minus is given in the question VL. Then you can take as a first terminal as sign the minus of V1 plus after that this one plus VL after that this one plus VC is equal to 0. In this case, you can say V1 is equal to VL plus VC. I am written this thing from KVL only. Without KVL, you can't say directly V1 is equal to VL plus VC. You have to follow the
Okay, sir.
KVL. You have to follow the KVL. KVL and KCL anyway. Yes.
Can you fill the problem from the beginning? My network connection is very poor.
This question.
Yes, sir.
Okay. Simply you can follow the KVL here. What the some reference as a VL. I have taken as a voltage of VL across the inductor, VC across the capacitor. Then you have apply the KVL in this loop. Then you have to follow any one references. If taken as the first of sign, then take the all element first sign only, not a second sign. Then I have taken the first sign, the minus of V1. This is the first sign. After that, this one plus of VL, then plus of VC. In the loop is equal to 0 by the KVL. Kirchhoff voltage law. So in a loop, all the voltages will be sum of the all voltages will be 0. Then you know VL is equal to VL plus VC. Then you have to find the VL and VC separately. After that, you can simply add here. Here is current waveform is given in the question and asking simply VL, VC. We have to find the VL and VC. I written this one in the bigger. L di by dt, VC and I dt.
Why this diagram is for?
For the current, this current is flowing I1. Diagram is given I1, then you have to find the voltage. Current is given in the diagram. When waveform, you have to find the voltage across the inductor and capacitor. Finally, you have to add to both to find the V1. Simply, di by dt says that rate of change of current with respect to time. Asking at 5 millisecond. This is the 5 millisecond. Inductor slope is here at 5 second for the inductor. Inductor not store the voltage. It will store only current. In the voltage waveform, you have to simply follow this slope. Then what is the slope? This one. Di by dt. Current is 5 to this is here is 0. This is 0 lines. This is the 5 and 0 minus of 5 changes. This is the 5 minus of 4 is equal to 5. Sorry, minus of 5 ampere per second. This is given in milliampere. This is given as millisecond. That's why this is the milliampere, millisecond. Milli will cancel out. Only ampere and second is remaining. Then di by dt is fine. Then what is the VL? L into di by dt. Inductor is given as 0.4 Henry here. Then you can apply 0.4. Di by dt is minus of 5. This one will be minus of 2 volt. Okay, VL is fine. But in the case of VC, we have to find the VC. VC is equal to 1 by C integration of I into dt. And you know about this one, any integration is showing as the area under the curve, or find the total. Here the capacitor is property to store the voltages. in form of voltage. Then you have to check the all of the waveform. Then you can say at the final time what is the voltage at the capacitor. And this thing I divided in many parts. I divided this one the area 1, this one area 2, this one area 3, area 4, area 5 at 5 millisecond till 5 millisecond. A1, A2, A3, A4, A5. You have to calculate the all area. Then if you integrate this one, then you find the charge. You know about charge, na? Q is equal to CB. Capacitor is given. Capacitor is given. Then what is the voltage? Total charge divided by a capacitance. Then you have to find the charge. So what is the charge? dq by dt is the charge. I. Then Q is equal to integration of I into dt. Same thing in the first question. I think this is the first question. I find the charge, integration of dt. The integration of dt is showing as the area under the curve. Any integration, first integration only. This is the first order integration. It means it showed the area under the curve. Then you can find simply area a1, a2, a3, a5. Then add all of the area. Then you can say the final charge. What is the area A1? Simply you can see here the triangle.
Sir, we can't cancel like the area under the curve for A1, A2, A3, A5.
Yeah, you can cancel also, but you can't say exactly what is say. That's why I calculate all the area, but you can simply cancel out also. Okay, in the final one you can see we see the all of the cancel out to each other. But now at this time I want to solve all of the area. A1, you know about triangle, area of triangle, half, base is 1 and height is -5. This will be minus 2.5. This is the milli. Second, this is the milli ampere. Milli will be micro coulomb. This is the charge. Area under the curve is charge. What is the A2? Same thing, same area, half into time scale as the base is 1, maximum point is -5, same as the minus of 2.5 micro coulomb. Okay, area, third one here, this is this area, same half, triangle area, time scale base is 1, final is 5. This will be a 2.5 microcoulomb. A4, what is the A4? Area of is rectangle, 5 into time scale 1 is equal to 5 microcoulomb. Then A5, what is the A5? A5 will be same thing, half into maximum height, 1 is the base, height is 5, equal to 2.5 microcoulomb. What is the total area? A1 plus A2 plus A3 plus A4 plus of A5 is equal to minus 2.5 minus 2.5 plus 2.5 plus 5 plus 2.5 is equal to 2.5 2.5 5 will be cancelled out. The final is 5. Okay, total area is 5 microcoulomb. Total charge, this will be total charge, you can say Q. And what is the voltage? Vc Q by C. Q is 5 microcoulomb divided by F. C, capacitor is given as 2 microfarad. Then 2 microfarad. This will be 2.5 volt. Then what is the V1? V1 is equal to VL plus Vc. VL is given as minus 2, calculated 2.5. This will be 0.5 volt. This is the final V1 voltage across the current source. Okay. Simply you have to calculate the charge for the calculating the voltage across the capacitor. You have to calculate total charge. And you know about total charge. Q is equal to integration of I into dt. And the integration, any integration is just simply shows that the area under the curve. Then you can calculate simply area all of this. Okay. Next question here, find the voltage drop across the current source in the
Sir, I
yes.
have a doubt.
Okay.
Yeah,
Enter.
in the above question,
Yeah.
we are calculating the total charge as A1 plus A2 plus A3 plus A4 plus A5. But
Hmm.
instead of doing that, we can directly calculate total charge Q equal to di by dt. Is it right or not, sir?
Q is equal to not di by dt na. T is equal to integration of I dt. Q is equal to.
Calculate di by dt formula.
You can calculate di by dt. Okay, but Q is equal to integration of I into dt, not a di by dt. Then you have to integrate all of things.
Okay, sir.
Not to differentiate. Then for the integration, you have to make make the all of the this waveform in expression I and t. We have to calculate the all I in a t format. Then after you can say you can integrate that one. After that, putting the I is equal to t is equal to 5 seconds, then we will calculate that one. Or simply calculate the expression of this current in terms of time. Like this is the linear equation. Then first calculate this linear equation from minus 5 to 0. Then after you use this linear equation, then after you constant this one, then after you have to check this one. Then you have to express find the expression of current with respect to time. Then after you have to integrate that one, then put the value t is equal to 5 seconds in that formula, then you will find direct. Okay.
Okay, sir.
Like a line equation, you can find the expression like line equation. You know about the line equation, y minus y1 is equal to y2 minus of y1 divided by of x2 minus x1 and x minus of x1, like that. You have to apply all of this formula for the all this expression, this equation, this equation, this equation, this equation. This is the constant one 5. You can simply, but this equation, this three are required for you from this one. Then add all of the equation of the linear. This is the linear equation. Then find the integration of that one. After that, put the value t is equal to 5 seconds, 5 milliseconds. Sorry. Then we will find answer. Find the voltage drop across the current source. This is the current source. I have taken as the voltage as V. Okay. In the diagram given below, this is the 15 volt of voltage source, DC voltage source. You can see here the DC voltage source R1, R2 have a simple 1 ohm and 9 ampere of the current source. Asking about the voltage drop here at current source. But here is a 5 nanosecond of capacitor. This is the capacitor. And you know about the capacitor, any capacitor only count the voltage source, a DC voltage source. In that case, the capacitor behave like an open circuit in a DC. Current will be not flow. Current will not flow in the capacitor in DC steady state. That's why this circuit will be break down. Current will not flowing through it. Then this current is flowing simply that. Sorry, current source is there. Then this current source is simply flowing like that. Then you have to find the voltage drop here. Okay. This current source flow the current from here to here only because of direction is given already in the current source. That's why this current is flowing. If there is some resistor or there is not capacitor, then some current is flowing here, then some current flowing through here. But here is a capacitor, then capacitor makes the open circuit. That's why whole current is flowing through it. And this have some voltage drop. This is already 15. Then we have applied the KVL. Someone asking about this one. There's a lot of messages here. Okay. There is an basic other plan of 30-minute meeting to record longer meeting of it. Yeah, what is this? Okay. Okay. Then apply the KVL here. Simply you can apply KVL here to here and here to here. You are free. If apply KVL here to here, opposite of the current, then you have to written like that, or you can apply KVL here to here. From here, first sign is negative, minus of V, then plus 9 into 1 ohm, plus 9 ampere current and 1 ohm, then plus 15 volt is equal to 0. Then what is the volt? V. 15 plus 9 is equal to 24 volt. This is the final answer. Okay. Simply capacitor is present and remove this one. If there is any inductor, then inductor will be short circuited in DC circuit. Okay. So next, consider resistor shown above, sorry, below here. If you apply the 5 volt across it, We
Sir,
observe
can you tell the problem before?
this one. This is simply if this is a ground, it means the circuit is completed here, and the capacitor is not present. Capacitor is present here. It means this branch will be open circuit. In this case, you can modify this circuit like that. This is a 15 volt. This is 9 ampere of current. This is 1 ohm resistor. This is voltage you have to find in the question. Current flow through it. This one. Then apply the KVL in the loop. In the KVL, minus of V plus minus in a resistor, capacitor, inductor, take the positive terminal where the current is entered. Current is entered here, then this is the positive, this will be negative. Take the always these references. In the resistor, current is passing through the positive terminal. Okay, this is positive, negative, the current is flowing like that. Then apply the KVL, minus of B plus of 9 into 1 plus of 15, first sign. Then we have to find the KVL is equal to 0. Then voltage directly 9 plus 15 is 24. Okay. Next is given as a resistor box is here. Suppose current is flowing through it is I, and voltage drop cross it is V.
Sir,
Yes.
I had a doubt.
Yes, sir.
We can solve sixth problem with a AC source.
There is not AC source, no. This is a DC source only. If there is a AC source, then you have to consider the capacitor.
Uh, ki- can you calculate it, sir, with an AC source?
If there is a AC source, then you have to find the reactance of this one. You know about the reactance of XC, it will be 2 pi 1 by 2 pi FC, na? 1 divided by 2 pi
Yes, sir.
of FC. Then there is a frequency in the AC circuit. The frequency is there, then you have to find the XC. Then after you simply apply this one R C load like that. In
Okay, sir.
that case, we have to find impedance R plus JXC.
Sir.
Okay. Here the DC source, then frequency is 0 in this case. That's why the X is equal to infinity ohm. This is the simply impedance. If the impedance is infinity, it means the circuit will be broken. It means open circuit. If the impedance is 0, that means the circuit will be short circuit. That's why here the open circuit in the capacitor because of the DC source. If there is AC, then you have to find the impedance. Then after you apply the all the impedance formula and calculating the current in AC source.
Okay, sir.
Okay, thank you. This is a given as if you apply 5 volt across it, you observe the X ampere of current passing through it. Okay. If you pass the 7 ampere through the resistor, you can see a voltage drop of X plus 2 across it. Okay, now find the resistance. Simply you know about this one, V is equal to IR, Ohm's law. First question is given, you apply 5 volt. If you apply 5 volt, then we observe current is X passing through it. Then X R. Question number second. Then if passes the 7 ampere up through it, resistor, then you can see a voltage drop of X plus 2 across it. Then voltage drop is X plus 2 when you apply a 7 ampere of current. I is 7, R is 7. There are two questions. You can solve this one to find the R. There is two variable, two equation. Simply take the x common here. X value, this will be 7r minus up to this x plus the here. From 2 equation, 5 is equal to x in place of x, this will be 7r minus up to into r, this will be 7r square minus up 2r. Then what is the final quadratic equation? This will be 7r square minus up 2r minus 5 is equal to 0. This quadratic equation you can solve by using this will be 7 r square minus 7 5 and 7 ja 35. You can say this one was 7r plus 5r minus of 5. You can break this 2r into plus minus 7 plus 5. Minus 7 plus 5 is equal to 2 minus 2. Then this is a minus 2r. You can common 7r here. Then this will be r minus of 1 plus you can common as 5. This will be r of minus of 1. Then this will be r minus of 1. 7r plus 5 is equal to 0. You can solve this one by equating to 0. R is equal to 1. Then you put 7r plus 5 is equal to 0. Then r is equal to minus of 5 by 7. Oh, because of the resistance is not a negative term, that's why this will be a correct answer. R is equal to 1 ohm. Okay, this is the answer, 1 ohm. Simply read the question carefully and apply the formula according to this one. First of all, a question is given. If you apply a 5 volt across it, then you observe x ampere of current passing through it. It means you apply the 5 volt, this one, then x ampere of current flow. Then equation is 5 is equal to V is equal to IR. It means 5 is equal to XR. Then after you passing through 7 ampere current, then the voltage drop of this through it is x plus 2. Then x plus 2 is voltage drop 7 ampere and R. Simply here also V is equal to IR. Then you can in this case you have to find the x here, then putting the x into equation 2, then you find the final resistor by solving the quadratic equation. Okay.
Sir,
Yes.
I
Yes.
have a doubt.
Yes. 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 Tell me.
Sir, despite of doing this process, we can solve this problem in another way, sir.
Yes. Yes. You can solve anywhere.
I
Yeah.
think resistance will be constant. So 5 by x and 7 by x plus 2 both are equal. You can equate both the equations and get the total resistance, sir.
Yes. Yes. You have to find the x value. Then after you find the r. Same value. Same process. Process different, but value is same.
Sir, can you do that method for me?
Okay. No problem. Simply take this two equation. Okay. Then find the value of r here. It will be a 5 by x. Then find the value of r here. X plus 2 divided by of 7. Then both are same. Then you can equal 5 by x is equal to x plus 2 divided by of 7. This will be 35 is equal to x square plus 2x. Then this will be x square plus 2x minus of 35 is equal to 0. Sorry, now you have to solve this one. X square plus of 7x minus of 5x minus of 35 is equal to 0. X will be common. X plus 7 minus 5 is common. x plus 7 is equal to 0. Then here is x minus 5 and x plus 7 is equal to 0. Then x is equal to 5 and minus of 7. Because of here, if you put in the negative value, then this will be cancelled out. This will be negative resistance. The negative resistance is not in physical existence. That's why you have to take in as x equal to 5. Then r is equal to
Sir, the
5.
answers are changed, sir.
Yes.
In your way, answer is changed, sir.
Same thing, one number, na? This is the x value, not a resistance.
Sir,
Yes.
5 by x equal to x plus 2, 2 by 7. Here we multiplied 7 into 5. Where do you get another 5 to divide, sir?
This is the x value, na? 5 is the x value, not r value here. If we equal both, 5 by x is equal to x plus 2 divided by 7, na? Because of both are the r value, then we have to equal both. Then this is the x value. After solving this equation, find the x value, not r value. Then for the finding the r value, you have to put any equation, or this one or this equation. In this equation also you can put r is equal to x is equal to 5 plus 2 divided by 7 is the same answer. 7 by 7 is equal to 1. If you're putting the same x in here, this equation, then we have to find the same answer, 1.
Okay, sir. I thought it has the direct R value, sir.
No, x is the x value, not the r value. You have to find the r after the x by putting the x value any one equation in these two equations. Okay. The next question is given in the give figures on this one. They has given this, there are constant current and voltage source. It means this and this is the constant current and constant voltage. Like if you take as a V, this is taken as a I. Then with the variable resistance, this is the variable. If someone increase the resistance linearly with respect to time, as shown below, not above, this one. If the resistance increases linearly with respect to time, then what does the graph of voltage across the current source V? This voltage is asking. Looks like. Okay, first of all, I write this one. This is the current source. This is the resistor. This is the voltage source. Okay, this is the variable resistor R. Current is I. This is the voltage VI. Asking about this voltage. This voltage is V. Then you can apply KVL here. Current is flowing through it like that. Then what is this one? So minus, this one plus. Then by the KVL, minus of V plus of IR plus of VI is equal to 0. In the question asking about the VI, then what is the VI? VI is equal to V minus of I into R. But in the question is given that this both are constant. Then V minus I R. This is the constant, this is constant, there is no changes. Then what happened? If vary the resistor linearly, if this is the increasing, it means this will be subtracted from V total voltage minus of I into R. R is increases, current is same and voltage is same. Then what the means? Total value will be reducing because of the subtraction. If resistance is increases, the voltage will be decreases. If the any waveform is there is a decreasing in the voltage, that one is the correct. Is a constant? No, this is not possible because of the resistance is increases, then voltage drop is happening there, then voltage across the current source will be decreasing. This is increasing, not this is also increasing, not this is a decreasing value. That's why this will be correct. Voltage across the current source will be decreasing. Okay. Fine. Yes, yes,
Sir, can you scroll the yes, yes.
yes, sir. What happened here? Any doubts?
No, sir, I am just watching the
Okay, okay. Simply, if you increase the resistor, that means there is a voltage drop, increasing across the resistor. Then the total voltage of the current source will be decreasing. Okay. Fine. Next,
okay, sir.
next question is find the V1 in the circuit given below. Current is given I. Sorry, this is not I only. This is the I1. This is the I2. Okay. Not both are I. This is I1. This is I2. Oh, what? One I2 is given. Asking about the voltage V1. This is the principle of the mutual inductance. Mutual inductance occurs where the two inductance are placing together, but there is a not electrically connected between them. There is a coupled inductor. It means at the same core, if you taken as the two winding is there like a transformer, then there is a some mutual inductance finding between them. If a current is passing in the one winding is there, then some of the current or voltage develop in secondary winding because of the mutual inductance. Same phenomena occurs in the transformer, you know about that. Then here also in the couple inductor. Couple inductor is not same as the transformer because of the transformer has a different thing. But a couple inductor it means there is a two winding at a simple single core and there is a mutual inductance between them. The mutual inductance effect is depending on the dot connection or a polarity. If there is a same polarity, then simply you can add both. If there is a opposite polarity, then there is a subtraction between them. Okay, finding this one. If you find this one, the current is passing through a dot. Here is a dot, enters from dot, but here enters from not dot. Then you have to find this one. If there is a difference between them, so current is passing through dot and secondary winding is there is a one dot that our current is leaving from the dot. In that case, the voltage will be opposite sign. The effect of that current in the primary side is the opposite. You can apply KVL here. Then what is the V1? This is some current is passing through here, voltage is here, minus of V1 plus current of I1 is here, inductor, suppose this inductor is L1, this inductor is suppose L2. V1, this will be L1, you know about d I1 by dt, voltage across the inductor. Then after I have some mutual inductance between them. Same thing, suppose I written as dot connection here, dot is here. Dot is defining the winding nature of winding, how you winding this one, clockwise or anti-clockwise, like that. Current is I1, this current is I2, this voltage is V1, this is L1, L2, V2. Okay, M between them, mutual inductance M. If there is opposite polarity is there, dot is entered here, but here is the leaving from the dot current, then there is a negative between them, minus of M. Okay, mutual inductance M from the secondary side current. Secondary side current is flowing is I1, I2, then this is the I2, sorry, di2 by of dt. Then what is equal to 0, loop is completed, like that, is equal to 0. Then what is the V1, L1?
Sir,
Yes, yes.
sir, what did you denote it by L1 and M?
L1 is the primary winding inductance, M is the mutual inductance.
Okay, sir.
Dt minus of M di2 by dt. Then what is the V1? L1 is given as 2 Henry. I1, I1 is given as 6 sine 2t. 6, sorry, d by dt. 6 sine 2t minus M, mutual inductance is 3 Henry is given. 3 d by dt. I2, I2 is given 5 sine 2t. Differentiate this one, constant is outside, 6 2 ja 12, differentiation of sine is cos 2t, then differentiation of 2t is 2, minus of 3 5 ja 15, sine differentiation is cos 2t into 2, this is a 24 cos 2t minus of 30 cos of 2t, this is a minus of 6 cos of 2t volt. S, in doubt, Govind Kumar?
Hello, sir.
Yes, yes.
Sir, I didn't understand the concept of mutual inductance. Like, how does this work? Like that mutual inductance thing minus M
Oh,
di2 by dt.
okay. Mutual inductance is same as inductor, but it will find a form from the another current, not the same current. That one known as the mutual inductance. It means this is affected from another any other thing. Like that, simply I had written a inductor. Suppose L1, L2. Okay, same thing connected in series. Suppose if there is a connection, it means there is some. This is the electrically coupled, electrically connected system. In this case, if the current is flow I V1 V2, then you can say as V1 is equal to L1 d I by dt, because of the same current is flowing through it. V2 is equal to L2 d I by dt. This is a electrically coupled system. This is a two inductor Okay, connected in series.
Hmm.
Okay, then this is the different thing. Formula is V1 is equal to L1 di by dt, L2 di by dt. Okay.
Okay, sir.
Ah,
Uh,
same thing. If there is any coupling is there, it means this both inductor is placing at the same point, as same places, now nearer to each other. Then there is some effect between them.
hmm.
First one,
Mutual.
first one affected to the second one affected to the first one. It means, yeah, yeah. This is a,
Imagine it like a magnetic field lines.
yeah, same thing. If there is an inductor is placing anywhere, then this is generated the magnetic field. Then that magnetic field is affected to each other because of the current is flowing through it.
Yes, sir. Yes, sir.
If there is any interconnection, if there is any disturbance between, or this is the any one is affected, if these are affected from each other, then there is occurring is a mutual inductance. That mutual inductance is depends on the direction of the current. If the both are the same direction, okay, same current, same direction. In this case, V1 is equal to L1 di by dt plus, this is because of the same current flowing through it here also. This will be M, inductor is here, mutual inductance, M di by dt. Okay, because of the same current is flowing here.
Like sir, like here, both inductor are in series, and
Uh,
in both inductor the same current is flowing.
yes,
That's why we use plus sign,
yes, yes.
plus di by dt.
Both have current have a same sign. Okay.
Okay.
A other thing. Suppose if this winding is a clockwise, both winding is a clockwise. Na, there is a winding, there is a core. You have to winding there. So you can winding the clockwise or anti-clockwise. Anything you are free. You can do. Suppose there is a clock. Both are clockwise winding. Okay.
Okay.
If both are clockwise winding, that means both dot connection is the same. Current is flowing from same point. Na, both have same
Yes.
magnetic field is the same. But suppose current is same, direction will be same, but there is some one is clockwise.
Sir, what did you say?
Okay, if there is a winding, two inductor is connected in series, electrically connected. Suppose two inductor is connected in series, but one winding is clockwise, second winding also clockwise. In this case, both current is flowing same direction, flux will be producing in the same direction because of the current and winding is same. In this case, we have to plus point here, positive, because of the dot will be same. Dot is denoted as the direction of the winding. Both are the same direction or opposite direction. Okay. Now, if suppose one winding is a clockwise direction, secondary winding is a second wind anti-clockwise direction. In that case, this dot will be a hair. In that case, it means in this inductor current is entered from dot, but here is current is leaving from dot. In that case, V1 is equal to L1 di by dt. Mutual inductance will be negative di by dt. Dot is denoted as the direction of the winding because of the flux will be changed. Flux direction will be changed according to the direction of the winding.
Sir, what when will be negative?
Because of the direction will be changed of the flux direction will be changed because the winding direction will change. Suppose a piece of wire, suppose current is flowing like that. Okay. current flowing from bottom side and come from upward like that. Finally, it looks like that. Can you imagine this winding? Current is flowing, this is the core, this is the core flowing from bottom side and coming from upward like that. You can say this will be the anti-clockwise. Can you see this winding is anti-clockwise? Current is flowing like that. Can you imagine this winding is anti-clockwise or not?
No, sir. Like this intuition, we
This
are not getting.
okay. Can you see this current is goes from bottom side of this core. This is the core. Suppose a
Yes,
piece of
yes.
iron. Bottom side then is come from upward. Then go to bottom side, then come from upward like that. In this case, suppose current is flowing like that. Na, it means current is flow from bottom to upward of the piece. This iron goes to bottom side, then come to upward. Na?
Sir, if we look from like left side, uh, we can see like it is going clockwise. No?
Looks from here only.
Yes, sir.
Uh,
From
cu-
there on.
current flowing through it. This one. Then current is go from bottom side, then comes to upward.
Okay. After that winding, it looks like going anti-clockwise.
Okay.
Yes.
Don't go.
From
It means bottom to top.
yes, bottom to
Then
top.
simply you take your thumb. Sorry, you have to palm na your finger. All of the finger and thumb is there na.
Yes.
Then put the all fingers direction in the current.
Mm.
Then what is the thumb direction? Is here.
Like,
Thumb direction is here.
yes, yes.
This is the flux direction.
Mm.
Okay.
Mm.
Oh, same thing. Wait. You can understand by same winding. I do like that. Okay. Then current is
Mm.
flowing like that. Imagine this one. This current.
Mm.
Then this what is mentioning this one. Current is flow like that. Can you say the current is flowing from top to bottom?
Yes, from top to bottom.
Then put same thing, same finger from top to bottom like that. Turn your finger from top to bottom.
Then it will
You
left
use your hand.
between left.
Use your hand. In this case, what happen? Flux is this direction.
Yes.
In this direction, flux is come from here to here. Magnet. This is the north south. This is the south. Na.
Mm.
In this direction, flux is flowing like that. This is north. This is the south. Same phenomena occurs in duct here. Dot connection. Simply, if you reverse the winding, then this is the reverse the flux direction. Then it will not compulsory the both in the both direction flux will be uh, supposed to secondary winding also not. Sometime it will oppose because of the direction of the flux. If the direction is the both direction is the same, then the flux will be supposed to secondary. But sometimes it will be opposed because of the direction of the flux. Then that dot connection is represented that one only.
Like dot represents clockwise.
Ah, you can say anything. A dot is the clockwise, so simply take it as a clockwise. On dot it means anti-clockwise. Then there is a difference between them. Then
Mm.
both flux will be opposite to each other. If both fluxes will be opposite, it means this will be negative. Mutual inductance will be negative. If the both flux is supported, supposed to each other, then there is a positive. Okay, understand?
Okay, got it. Thank you.
Oh, simply this is the phenomena of the direction now. In this case, you can see the current is flowing from dot, but leaving from dot. Second current is leaving from dot. That's why this is the opposite to each other. Opposition, this one. That's why there is a negative point.
So in the case of mutual inductance, the first diagram will be linked in positive and the other one is negative. The flux.
If there is a supporting flux, it means the both are current enters from the same point, like a dot connection. The both are entered from dot. In that case, M is will be positive. If there is an alter change between dot connection, then there is a negative M. Simply you understand this one. Like that, this is the opposite. Current is flowing from opposite one. That means there is a negative. Next question, you can say.
Sir,
Yes, yes,
can I ask one more?
yes, yes,
Like
yes.
here,
Uh,
can you represent with flux like both the dot, like from like in V1 side, flux will be from bottom, like north will be in bottom, south will be in dot side.
no, same thing. If there is a winding, okay,
Hmm.
and current is flowing here, it means in the winding you have to point the winding a current, like it fingers represent the current, thumb represent the uh,
Direction of flux.
direction of flux.
Hmm.
Simply, if you can check, this was the clockwise because of the dot is entered from this one, the clockwise direction. That means flux will be upwards. This one flux will be like that. In this case,
Hmm.
flux will be like that. Both are opposing to each other, opposing to each other. Both are not
Hmm.
supporting to each other. That's why there is a negative point. Okay.
So, but
Yeah, yeah.
like in 4 Henry inductor, like current is going from up, and I2 is going from upside.
No, no. Current is because of dot. You only see the dot connection. This is the dot. This is the dot. This current is
Hmm.
flowing. This is enters from dot. This current is leaving from dot. This is not enter from dot. Same thing
Okay,
here.
no,
Here, same thing.
oh,
Enter from dot, leaving from dot. That in this case, this will be negative. If both are the same, enter from the same dot connection, then this will be positive. There is a positive.
like sir, in question the representation I2 doesn't give direction of current here, like I2 direction.
No, if there is not direction is given, then you can't be said where is a positive or negative. If there is not a dot connection is given, then you can't be said.
Okay.
There's a
No, sir, like the upper side representation of I2.
there's a given a direction. If they
Yes.
if the direction is not given of I2, then you can't say na where is the enter from here or here. Then there is
Okay.
a controversy there. So that's all to each other.
Okay. And that dot represent that like leaving from there.
Uh-huh.
Current is leaving.
Yes, yes,
Okay.
yes.
And leaving current gives the direction of flux. That dot only, not
Yeah.
I2.
Yes, yes. I2 same I2 current flow is na.
No, sir, like if that dot is not given and that I2 and direction is given only, then
Then you can't say without dot connection na.
okay.
Because of the winding can be reversed na, clockwise anti-clockwise. It could be. Then
Hmm.
you can't say directly it will be same as previous direction, primary winding direction.
Okay, sir. Continue.
Okay. This is a okay. This final na. This answer minus of 6 cos 2t.
Hmm.
Okay. Same thing here. You can see The both dot is same. Both current is leaving from dot. Then what happening here? Positive or negative?
Positive, sir.
Yeah, in this case we have to positive all. Okay. Same thing apply V1. V1 is equal to L1 di1 by dt. Okay, this is a primary winding. Then this is a mutual inductance MO. Then both are the same dot. Both current is leaving from dot. Sorry, this is a leaving from dot. Both current. It means M is positive. di2 by dt. Same thing we apply V2 for the V2. This is the L2 di2 by dt. Same current. Then mutual plus of M1 to secondary side wala, that one di1 dy by dt. These two voltages. Is there a matching option? I think this one. Both are positive because of the dot connection, and both current direction will be same. Is same because of both are current is leaving from dot. There's a question asking about the week 1 assignment, question 4 and 5, and question 1 also doubt. Will we get 1 ampere as answer? Remember current flowing at a not current flow. Recording and notes both are available after this lecture. Once I uploaded this video on the YouTube, then after I will share the link. I think in the next class, or you can search this thing in your NPTEL website. Is there problem solving session? If you go to the into problem solving session, there is a link of both in public sheet. You can see there. So then you can follow this one. Okay.
Hello, sir. Slide is not changing.
Okay. I simply checking the assignment first. That's why I will. Okay, fine. Let's do this question. Find the voltage across the following shape if the resistivity of the material is ohm and the current passing is I. What is the voltage? Voltage we know about V is equal to I into R. How is the resistance? You know about the resistance formula rho L by A, where R is a resistivity, L is the length of the wire, A is the cross section area of the wire. You know about the cross section area of the wire? It means simply if there is a wire is thick like that, then what is the middle portion of the area of the wire is a cross section area known as the cross section area. This is denoted as the A. A is equal to pi r square. Then r is given. Then you can say r, it means radius is given of the wire cross section area. The rho L by A is pi r square. Pi small r square. Small r is the radius of this cross section area. Pi r square is total area. This one, this area. Then putting the value V is equal to I into R is rho L divided by F pi R square. This is the answer. What option is there? I rho L I pi R square. I think this one. Second option. Okay. Next question is going to find the voltage across 2 kilo ohm resistor in the given below circuit. 2 kilo ohm resistor is this one. It's asking about the voltage drop. It means this is voltage drop, suppose V. Now VR, I taken as VR. It should be any positive, any negative, not the same, because of the there is a not mentioning sign in this question. Then you can say this is a positive, this is negative, anything. This positive, this negative, or this positive, this negative, anything is possible. But in the option is not given as negative, positive, then anything if you comes in your answer, then simply put the value, positive value is there. Check the positive value, not a negative value, because the negative value is not there in the option. Okay. For the solving this type of question, you have two methods, are nodal analysis or loop analysis. For the nodal analysis, simply I taken as voltage V here. Then what is the current? I taken as the current, all current is outside, like that. Then voltage V minus of this voltage V minus 12 divided by of resistance. Current is what means voltage difference between them divided by a resistance. So what is the voltage difference? V minus 12 divided by 5. I am not mentioning the kilo ohm, because of if the current is comes here, the current will be in milliampere, because of the resistance is kilo ohm. That's why I am mentioning directly here. Then this is outside, plus V minus of 3 divided by of 3 kilo ohm, plus V minus of 2 volt here divided by of total resistance 3 plus 2 is 5 is equal to 0. Nodal analysis, same KCL, all current at this node is equal to 0. You can take the LCM of 15, 3B minus of 36 plus of 5B minus of 15 plus of 3B minus of 6 is equal to 0. This 15 is go here, cancel at 0. 3B, 5B, 3B, it will be 11B minus 36, 15, 51 minus 6, 51 plus 6 is equal to 57. B is equal to 57 by 11. The node voltage is no. Then after this one, we have to find the current I. What is the current I? Is V, same thing, minus of 2 divided by of 5. Then V 57 by 11 minus 2 divided by of 5. Then 57 minus of 22 divided by of 11. Total divided by of 5. This will be 57 into 22 minus 22 is 35. 35 divided by 5, it will be 7. 7 by 11. Then what is the voltage V? I into R. R is equal to 2 kilo ohm. Then I into 2. this will be 14 divided by 11. This is VR, not a V. Then VR is equal to 1.27 volt. Okay. By Newton analysis, you can do like that. Same thing if you want to by the loop analysis, you can simply take a current, this one I1, this one I2, then find the I1 and I2, then after find the VR by multiply the I into 2 kilo. You can do this one like that also. Okay.
Sir,
Sir.
what is what did you denoted by VR?
VR is asking the question voltage across 2 kilo ohm. That's why I denoted the VR as a voltage across the 2 kilo ohm.
Okay.
Yeah. Any others?
Sir,
Yes.
when you do the solution in a loop analysis method,
Yeah, simply you can take the two equation I1 and I2. This is 3 volt. This is a 2 volt, 12 volt, 5 kilo ohm, 3 kilo ohm, 3 kilo ohm, 2 kilo ohm. Okay. Take a equation this one as I1. This equation is I2. And what is this equation? I1 minus I2. This current is flow is I1, then I2 is passing here. Then this I1 minus I2 current passing to this branch. Then take a loop, first loop here. Then you can take second loop here. Or you can take a second loop here also in total. Anything you can do. There is a 3 loop. Okay. Leave this one. I taken this one. Loop 1 KVL in loop 1. What is this one? This current flowing positive, negative, this one positive, negative, positive, negative, positive, negative. Minus of 12 plus 5 I1 plus this one 3 I1 minus of I2 plus 3 is equal to 0. Then 5 I1, 3 I1 is equal to 8 I1 minus of 3 I2 is equal to 12 minus 3 is minus 9. It will be positive 9. Equation number first. Okay. Same thing apply KVL here in this loop. I started from here. Minus of 3. This is minus of 3 I1 minus I2 plus of 3 this one I2 plus 2 I2 plus 2 is equal to 0. Minus of 3 I1 minus plus 3 I2 plus 3 I2 6 I2 plus 2 I2 8 I2 is equal to minus 3 plus 2 minus of 1 minus 1 is equal to 1. Equation number second. You can simply multiply by 8 in equation second. Then what happened? I1 is equal to 8 I1 equation first minus of 3 I2 is equal to 9. Same thing, if we multiply by 8 here, okay, multiply by 3 in 1 and 8 in 2. If you multiply by 3 here, then this will be a 24. This will be 3 3 ja 9. This will be 9 3 ja 27. If you multiply by 8 here, then minus 24 I1 plus 8 8 ja 64 I2 is equal to 8. You can simply add all of the, this will be cancel out. Now 64 minus of 9 is equal to 53 I2 is equal to 35. I2 is equal to 35 divided by 53. So sorry, 55. 64 minus 9 is equal to 59, 55. Okay. Then what is the VR? VR is equal to I2 into 2 kilo ohm. Okay. I2 is 35 divided by 55 into 2. 5 7 5 11. 14 divided by 11 is equal to 1.27. Okay.
Okay, sir.
Okay, then thank you class. I want to stop here. And the link of this video and this notes will be shared on the video is on the YouTube, and this link is shared on the public sheet.